Welcome back. In this problem, two small identical discs each of mass m lie on a smooth horizontal plane. The discs are interconnected by a light non-deformed spring of length L0 and stiffness x. At a certain moment, one of the discs is set in motion in a horizontal direction perpendicular to the spring with velocity v0. Find the maximum elongation of the spring in the process of motion if it is known to be considerably less than unity. So initially only one of the discs is given a velocity v0 perpendicular to the length. So it is the intermediate stage. So I used here a conservative law of angular momentum. So you can use center of mass velocity vcm equal to m1 v1 plus m2 v2 by m1 plus m2. So we will get same result as I got. So why net torque is 0 about center of mass is actually the spring force passes through the center of mass, so it is not taken into torque. So net torque about center of mass is 0, so we can conserve angular momentum. So I wrote L initial c about center of mass equal to L final about center of mass. So it is the final situation. We got center of mass velocity as v0 by 2, so we give it opposite to the both the masses, so v0 by 2 v0 by 2. So same as final situation also, v by 2 v by 2. Initially the length is L0 and finally the length is L0 plus x, so x is the elongation. So I wrote here in the place of m I wrote mu relative. So mu relative v0 L0 equal to mu relative v L0 plus x. So by this we got final velocity v, that is v0 L0 by L0 plus x. We assume this equation as 1. So the center of mass moves with the constant velocity, so kinetic energy is constant, so we conserve mechanical energy in the frame of center of mass. So u initial plus k initial equal to u final plus k final. Initially there is no potential energy because the spring is in natural length L0. So finally it expands at x. So initial kinetic energy is half mu relative v0 square equal to potential energy of the spring half kx square plus final kinetic energy of mu relative v square. So arranging this, we got x square equal to mu naught by k into v naught square minus v square. We assume this is equivalent to, from 1 and 2 we got extra elongation, x square equal to mu v naught square by k into 1 minus L naught by L naught plus x whole square. So in the question he said to use binomial expansion, so I wrote this as in numerator and this as denominator. So I got here minus 2. So here L0 is very greater than x, so I in minus 2 is get to here. So finally I got x square equal to mu v naught square by k into 1 minus 1 plus x 2x by L0. So cancelling x here, x is approximately equal to m v naught square by k L0. So I solve this using center of mass frame. So you can use another method also. So this is the easy method to solve this problem. So thanks for watching. If you like it, like, share, subscribe. Thank you for watching. Yeah.